Prove that for all positive integers n greater than or equal to 1, the sum of the squares of the first n integers is n plus 1, 2n plus 1 divided by 6. So remember our base case, and in this case, for n greater than or equal to 1, the base case is n equals 1. If we look at the left-hand side, it's just 1 squared, which is 1. If we look at the right-hand side, if n is equal to 1, we have 1, 1 plus 1, 2 times 1, which is 2, plus 1, over 6, which is equal to 6 over 6, which is 1. So it is certainly true for n equal to 1. So that is the base case proven. So we're now going to move to our inductive step. We're going to assume for n equals k. So what we're going to do is say that 1 squared plus 2 squared plus 3 squared plus and so on up to k squared would be equal to k plus 1, 2k plus 1 all over 6. Then look at the next case, k plus 1. So on the left-hand side, we are just going to add the next one. And then we're going to do the same on the other side. And the logical implication here is that if this is true, then this must also be true because I've just added k plus 1 to each side. So what I want to be able to show, and this is where it's a good idea to have a target expression, is that we're going to get this with k replaced by k plus 1. So in other words, we'll get k plus 1, k plus 1 plus 1, and 2k plus 1 plus 1 over 6. That's going to be our target expression for this. So, first thing I'm going to do is just give myself a common denominator, because when you've got fractions, that's usually a good idea. So I'll have 6k plus 1 squared over 6. And then what I'm going to do is take out the common factor k plus 1. And there's also common factor of 6 on the bottom. And if we do that, what are we left with? So from the first term, you'd be left with k and 2k plus 1. And from the second term, if I've taken out k plus 1, I've got 6k plus 1. And so I've got k plus 1 over 6. And then expanding out and simplifying, I've got 2k squared plus 7k plus 6. So let's see if we can factorize that quadratic. And then we've got k plus 1 and k plus 2, 2k plus 3 over 6. And that is k plus 1, k plus 1 plus 1, and 2k plus 1 plus 1, all divided by 6. And so we've done the algebra. And then you just need your concluding statement. Now, in this particular case, I would say that it is true for n equals 1. And if true for n equals k, it is true for n equals k plus 1. And therefore, it would be true for all n greater than or equal to 1 by the principle of mathematical induction.